Welcome to our webinar on water use in oil and gas activities. I'm your presenter, Ryan Rawlick, and I'm the hydrologist here at the BC Energy Regulator. A note that this presentation is available with closed captioning. To activate, please click on the CC at the bottom of your screen. So before I begin, I think it's important that I acknowledge that I'm making this recording from Fort St. John here in beautiful Treaty 8 territory, which is a region that I hold very dear to my heart, having had the privilege to both be born and raised here and also to be able to return here to expand my career and make this impactful work while partnering with local Treaty 8 nations. So a little bit about me. I am the hydrologist, but what is the hydrology? Hydrology in general is the study of the location, movement, and properties of surface water. My role is I provide technical support for water management decisions and work with all the nations to ensure that our resource is protected. So a brief overview of what we'll cover is our water management. We'll cover the water sources in oil and gas industry, how is it accessed by oil and gas activities, and what is it used for. Now, how do we regulate water use for oil and gas activities? Through the water licenses and short-term use approvals, both through the Water Sustainability Act. And most importantly, how we sustainably manage water for all needs and how we gather and utilize data to inform our decision making. So how is water used in oil and gas activities? It's used for many different things. Some of note are the purposes such as hydraulic fracturing, drilling wells, dust control, freezing winter roads and ice bridges for winter access, geophysical exploration, and equipment washing. So the two major basins within the Northeast are the Liard and the Peace River Basin. The Liard is the major tributary to the Mackenzie, whereas the Peace flows first into the Athabasca and then into the Mackenzie on its way to the Arctic Ocean. Now, to facilitate our management and better allocation of water resources in the area, we've delineated those two basins into their smaller tributaries, and we refer to them as the water management basins. So some of the water sources that can be used for oil and gas activities come from deep saline groundwater, flowback or produced water that comes out of the formations when they are doing their fracking activities. Also, there is reclaimed water that can be purchased from, for instance, the city of Dawson Creek, which reclaims their sewage water and then offers it for sale for the oil and gas industry. And then there's also freshwater sources, so streams, rivers, dugouts, lakes, and reservoirs. Here's just a small little infographic of the oil and gas activities water cycle, showing it's actually a very complicated cycle. And just a small amount, as you see circled there, is the surface water licenses and Section 10s, which I'll go over in depth in later slides. So something that we really use quite often in hydrology to make water decisions is comparison of weather and climate and review of those conditions. So first of all, what is the difference? Mark Twain put it very eloquently back in the day that climate is what we expect and weather is what we get. And this can be seen in this plot basically of the monthly climate averages between temperature and precipitation at the Fort St. John Airport. If we focus in on the month of May, we see that May has average precipitation of approximately 37 millimeters in that month, whereas in 2023, at the bottom, you can see that we received 65.7 millimeters that month. We also can look at daily average temperature for the same month is approximately 10 degrees Celsius in Fort St. John for those monthly averages, whereas in 2023 we had 15 degrees Celsius, so towards that top end of that daily maximum temperature. And this really shows the variability that weather can present when looking from long-term climatic conditions. Thing that we really need to look at when making water decisions for allocations is the current water state. What is the current water level in stream systems that are potentially being allocated, and how do they compare to those long-term averages and other maximums, the extremes and the maximums and minimums? So One important tool that we use is the water portal, which summarizes all stream flow stations where they monitor stream flow. And this summarizes all that data into somewhat more digestible statistics so that you can compare where those current conditions are and where they lie between those extremes and within those averages. Clicking on one of the Water Survey of Canada stations, the Halfway River above Graham River, this will pop up and display a hydrograph, which is basically how a stream system behaves over the season. This you can see all the way from October 2022 all the way into March of 2023. And what you see in the blue line is the flow within that current year. And then all those different gradations of gray and orange are the different statistics. So you've got the medium flow in orange, and then you've got the minimum flows and the low flows in the lower grays, and then in the higher flows, you have them in the higher grays. And so this really helps us identify where we're at from a historical standpoint. Now, this zooming in on that same station from the Water Survey of Canada Aquarius portal is another way to really make sure that we are identifying what that real-time flow is looking at. So I've clicked on that same point, and you can see you can generate a plot of how it looks over the season. What you see on the right picture is that same hydrograph that was shown on the previous slide. And then you see those manual measurements that are actually gone out, taken by Water Survey of Canada techs to make sure that what their sensors are reading is accurate and representative of the actual conditions. Another thing that we look at, especially in these early seasons, to see what kind of season we may be looking for in a summer and early spring, is the snow pillows. So snow pillows essentially are a measurement device that is on the land that measures the amount of snow on it and converts it into a snow water equivalent. So however much water would melt out of that snow from melting. This is a snow pillow from that same area. It's called Crying Girl Prairie is the location. And again, it shows the current year, 2023 to 2024, in the blue line and how it compares with the historical averages and medians, and then also the previous year. So as you can see, from when this was developed in January, snowpack at that area is currently quite low and has been slow to increase. So we're hoping for a positive change in the next few months of that. So I keep on talking about water units, but I haven't really referred to what we are meaning. So we often refer to river flow as cubic meters per second. So a cubic meter is a meter by a meter by a meter. And for every second it is flowing through that system, you can assume that that amount of flow is flowing through that system. So if a stream is flowing as a regular annual mean discharge of 20 cubic meters per second, you can assume 20 of those meter by meter by meter cubes flowing through every single second at one specific point that you're looking at. So another way to put this into context is water trucks. We see these quite often in the Northeast and in rural areas, especially when people rely on water delivery for their potable water. One of these fixed body trucks carries approximately 15 cubic meters of water. So as I mentioned, we have authorization under the Water Sustainability Act to issue both short-term and long-term permits. So one of them being Section 10, which are short-term use approvals. They're only good for up to 24 months, so shorter time period. They're typically associated with smaller volume requests. And often when an operator is looking for a longer term license, they will apply first for these short-term use approvals so that they can then use that to gather data while they're using the water and make it a more fulsome application package so that we have more data to rely on to make that defensible decision. Section 10s also have, they typically have drought condition restrictions and are also subject to suspension in times of drought, which has been evidenced over multiple years over the past few years. So the next is the longer term, the Water Sustainability Act Section 9 licenses. These typically go from 2 to 20-year terms, and they really facilitate longer term development plans and are more of a guarantee because they will get cut off last comparatively to a Section 10. As well, there is a higher level of scrutiny and detail required for these, and in order to do that, that's when you have that additional amount of information that you would supply with your application package that we can review. And then we also typically establish drought conditions as well. So environmental flow needs thresholds. We have mandatory pump rates that they cannot exceed throughout. And we make sure that there is a higher level of scrutiny on these. Two of the most important decision-making questions that we have here when looking at allocation is, one, how much water is required for the environment and other users? And two, is there any water available for allocation? And the answer inevitably always is, it depends. And it depends on a number of things: natural variability, the location of the source, the environmental sensitivity of it. Are there other users on it? Are those other users agriculture? Are there water providers? Is there recreation values in that system? And what data and information is actually available for us to make that decision? This is where we make use of Section 15 of the Water Sustainability Act, which references the environmental flow needs of a system. And we follow the provincial environmental flow needs policy in that EFN, or environmental flow needs, is the volume and timing of a water flow that is required for the proper functioning of the aquatic system. And typically with the EFN flow needs policy, all water users and withdrawals added together cumulatively total no more than 5 to 20% of the water flow. And at the BC Energy Regulator, we try really hard to maintain a minimum of at least that 85% of natural flow. So we aim for no more than 5 to 10% allocation in those systems. So to illustrate that, I've created this theoretical hydrograph to really illustrate what the EFN policy looks like. So we see flow from January on the left all the way to December on the right. And within that, you see that blue line, which is your maximum amount of flow. And then below that blue line, in between that and the gray line, is that 5 to 15% that is available for withdrawal. And then underneath that gray line, all that volume available is reserved for the environmental flow needs of the ecosystem. So all information on how to apply for either a water license or a short-term use approval for oil and gas purposes can be found on our website. All these links will be provided in the video description below. And there's lots of really good information within those, and what is required in an application, how to prepare your application, and what other things that may be required in order to facilitate a positive decision in your case. So I've put together an example of what we may see from a water license application with Mr. Rollick Inc. and his water license application. So some of what we would be requiring for this application are the point of diversion, or the POD. So what is the stream name? Where is it located on land and in the system? What is the volume of water applied for, both in cubic meters and preferably the pumping rate? We would really like to see what is the rate that you wish to be pumping at. Are you planning on doing it annually? Or are you planning on only withdrawing during a certain season, during the open water season? Do you have storage available? This is also very important to consider in these systems that have high flows in the spring and very low flows throughout the rest of the year. Are there other users upstream and downstream of the POD? And what are the percentage of the weekly or monthly average flows that are already allocated without considering this additional ask on the system? We may also require a hydrologic analysis, so identifying the weekly and monthly flows and what are the variability between those high and low flows throughout the season. And this would all come out in an environmental flow needs assessment to determine what type of flows would be required to leave in the system for the ecosystem to be sustainable. So here I've got a little map of where my applied for POD and license are in the little purple X and open triangle there. And as you can see, there's several other users on the system. and I've detailed, my annual withdrawal volume is 450,000 cubic meters. I am lucky that I have all that available for storage in an off-stream pit or pond. I've also included the season that I want to withdraw, my maximum pumping rate, and a summarize of the current diversions at that POD, and then also what are those with my requested pumping rate, what are the total diversions at my POD. So as part of my application, I've also completed a hydrologic analysis of the stream system that I'm applying for. One that plots, looks at the mean flows that, the typical conditions that one can expect, but also if that information is available, what are the minimum flows ever recorded at that, and what are some, representative drought conditions in the green line here. I have the 1 in 10 year low flow on this slide. Then go a little step further, and during those months that I've proposed withdrawals from April to August, I've got a summary in a table of what are those average flow conditions, the total diversions at my POD, the percent of those average flows that are already licensed, and what are those associated EFN thresholds with those flows. So then I also go forward with the potential allocations based on the EFN conditions and the percent of that 15% in this system that's already allocated. So these red lines are showing in the total diversions and the EFN thresholds. This assumes that all those water withdrawals can really occur at any time, all the time, to ensure that we're being as conservative as possible on this. And those EFN thresholds are based on those low flows. So below this threshold, no pumping is able to withdraw on this. So as you can see, August was 66.7% of the EFN. So that is something that I would probably not look forward in authorizing withdrawals during that month. And we may push back and say, you can have this license, but you can only withdraw during the months of April, May, June, and July in this case. So something that we may look at in authorizing a short-term use approval, Section 10, or a long-term license, Section 9, is monitoring conditions. So obviously this would depend on the application details, the source, the rate, the total volume, timing, etc. But we may consider this when needed. And then there's many different ways and methods to satisfy this, but it is really nice to be able to tie this to when there is an application on a system that has, for instance, a Water Survey of Canada gauge, because they really are the trusted source of data for those systems. So as an example, this section 10 that we have here is for the Beaton River, and it directly references flows between April and October at the Water Survey of Canada station near Fort St. John. And below those flows for each of those months, no diversions are able to be done at these times. Now I've got another example here on what you could expect to see in a Section 9 water license. Some of the conditions may specify the maximum quantity of water that you can have in storage, which I've indicated in the first highlight there in condition E. And then we also will have a condition potentially on the season. So in this one, for example, they are only able to withdraw water between the months of April 1st to July 31st. And then going down into condition K, this is when we have those environmental flow needs thresholds, which I showed in the previous slide as well. This is a slightly more detailed one. Bassett Creek is a much more sensitive system with lower flows in it. And so this one broke it up to the first few weeks or the last few weeks of April, the first couple weeks of the end of April to early May, and then the last couple weeks of May. Below that, nothing can be withdrawn, and then it also has a hard cutoff across the board of 0.07 cubic meters per second. So some of the other tools that we can really leverage, and also an applicant can really leverage to make a very useful and potentially more successful application, is resources such as the Northeast Water Tool, and outside of the Northeast, the BC Water Tool. There's several tools across the province. The Water Survey of Canada hydrometric data is fantastic to getting that well-trusted source of data for those stream systems that are monitored. This is also summarized really well in the water portal. Also, often proponents will conduct independent streamflow measurements so that they have that data available in areas where it isn't available that they can then provide and really aid their application. Also, that we look at potential hydrometric modeling. We always consider climate change, and there's a wealth of data out there, especially from the Pacific Climate Impacts Consortium. And then another way to determine, are there other users on your system? If you don't know, we can always look at the water license query tool through the province of BC. So I mentioned the Northeast Water Tool. The Northeast Water Tool is a very user-friendly map-based flow hydrologic analysis tool that basically is able to try to generate potential stream flows in ungauged basins based on the modeling from Water Survey of Canada flow gauges. This was originally developed in partnership from the BC Oil and Gas Commission, which we are now obviously the BC Energy Regulator. And since then, it has been expanded and adopted to other regions by the province. And this is a really helpful tool to help aid our decision making because it incorporates the environmental flow needs so that we're able to get a better understanding of what potentials are available for allocation in that system. And it does the cumulative effects, so it presents all the current water authorizations under both Section 9 and Section 10 for that system that you're of interest. So if I click on the map here, I will generate a watershed, and it will then produce a report of an area that I can expect what those typical flows are between the months of January to December. So I generated a watershed for a similar location to the Water Survey of Canada gauge at that halfway above Graham station. And what I've highlighted here in the red box is the potential allocations in risk management level 1, which we try to stay within at the energy regulator. And this is all based on the environmental flow needs policy. So it shows how much water is available within that risk management level for allocation to make sure that the source is still sustainably protected. A useful addition to the Northeast Water Tool in recent years has been also the addition for the drought considerations. So this draws from a number of Water Survey of Canada candidates that are modeled to be, estimated to be close to where that station is and what it's estimating the flow at. And it essentially gives you the flow percentiles from the 10th all the way to the 90th. Now, if you're unfamiliar, 10th basically means low. We know that if it's flowing at the 10th percentile, then 90% of the time flows are higher than that. So that generally reflects a 1 in 10 year drought and is quite low conditions. Whereas conversely, at the 90th flow percentile, you know that it's very high because only 10% of the time flows are potentially higher than that. Those flow percentiles and drought considerations are really helpful for identifying whether that water ask that an applicant is putting forward is at all reasonable and sustainable. If flows are only available higher than what they are projecting 10% of the time, that may not be something that is an economical decision to allocate that water. Now, another thing that you can use for the drought considerations is, again, the water portal, which, as I said, summarizes those flows based on current conditions and compares them to the historical conditions. So again, I've got this halfway river above Graham, and I've got October 2nd, 2023, and you see that 7-day flow percentile of 2023 is 13.47 cubic meters per second. And if I zoom down all the way to the 10th percentile, which again is representative of quite low flow conditions, you see that those 10th percentile flow conditions are just a little bit higher than what the current flow is, so 13.54. So that means that on October 2nd, 2023, flows in the Halfway River were actually quite low compared to historical averages. The water allocation principles that we follow very closely here when making these decisions is protect environmental flows for fish and wildlife, protect both present and future water needs for all users and First Nations, uh, understand and manage for natural variability and potential future change, and recognize and respond to unusual flow conditions such as drought. And we try to be fully transparent with information and decisions, and also, very importantly, collaborate and innovate. We don't work in silos, and we work very close with Treaty 8 First Nations and nations outside of the region, as well as other water allocation bodies such as Ministry of Waterland and Resource Stewardship. Follow these values through active and engaged water management by prioritizing the environmental and community water needs. And this is allowed by giving us the regulatory authority for Water Sustainability Act Section 9 and 10 authorizations. We constantly monitor river levels, and when necessary, we will suspend industry water use of water from rivers and lakes to make sure that we're protecting the water for the environment and for other people and users. And this is evidenced in 2023, where we issued 5 directives suspending Section 10 surface water withdrawals. And this occurred across the province in various basins within the Fraser, the Peace, and the Liard River watersheds, and encountered 37 permits held by 11 companies at 84 different areas for withdrawal. We actively monitor conditions across BC, and we work very closely with the Ministries of Forests and the Ministry of Waterland and Resource Stewardship, as I mentioned before, to really help identify other basins outside of the Northeast that may be in need of suspension. So if you're interested to learn more, we have a water information page or water management page that basically summarizes a lot of what I just went through in this presentation and goes a little bit more into detail in others. And there's some really interesting infographics and interactive tools that you can use to learn about water use across the Northeast and how it's changed in recent years. And we also, I may not have mentioned this previously, but all of our Section 9 and 10 authorizations have mandatory reporting conditions within. So every 3 months, they have to report all the water that was taken on a daily basis. Over those 3 months, they report it to us, and then we summarize it and publish it quarterly in our quarterly management summaries. If you go into our data and reports section, at the bottom there is a water management section that has all of the quarterly water reports summarized, and can get a lot more information out of those. So I would like to really thank you for sitting through this presentation and your interest. If there's any interest in following up or any questions, please don't hesitate to send me an email, and I will try to address your question as quick as possible. Thank you very much.